Hello, let's have a look at security and encryption. Why do we have usernames and passwords? Wouldn't it just be easier if we just used passwords? Let's have a look at an example of that. Okay, let's say we have someone called Jack, and they've already registered, and they have a password, pail of water. Let's say Jill registers, and she wants to use the same password, pail of water, and the system warns her that saying, actually, someone's already using that password. If Jill wanted to, she'd go, well, that's interesting, isn't it? I'll just try logging in using a pail of water, and look, I can get access to Jack's account. So we don't want that. Okay, so the system doesn't warn Jill, let's say. Yeah, that'll work, won't it? Okay, so when Jill puts in her password, she opens Jack's account. Okay, right, let's find another way of doing this. Jill isn't warned by the system, but it replaces Jack's login with Jill's. But the next time that Jack logs in, he gets into Jill's account. Okay, so none of those work. And in fact, if you just had passwords, the possibilities are that someone may put in a very simple password, which then may be repeated by somebody else, in which case they can access somebody else's account. And we just want to avoid it. It's not secure enough. So the way around it is say, well, let's use usernames which are unique. They may be known by everyone, but only one person can have that particular username. And if we then marry that together with a password, which doesn't have to be unique, but it's unknown, it's the combination of the unique password, username, and the not necessarily unique password, the combination of those together make a very secure way of logging in. Well, how secure? Right, let's say we've got someone who's put a password in called hacker. And what if someone wanted to go and try and find, I know your username, I'm going to go and try and attack the system saying, using that username, let's try and find that password. So let's say they do that every single second, and they're going to say, well, let's see if I can get into their particular account. If we did that once every second, we can see that 3,500 days. That's pretty good, that's pretty secure. But actually, speed-wise, that's not very realistic. Even your average kid hacker in a room in their bedroom can actually probably manage 1,000 per second. Well, that's more worrying, isn't it? 4 days. Well, okay, well, maybe, but governments, supercomputers, they can kind of work a trillion a second, in which case, less than a second if they got your email address or your whatever your username is. It's not very realistic, so we'll stick at 1,000 per second as being kind of where we want to be. So, English language, how many characters? There's 26 characters. But there's also lowercase and uppercase. There's not 26, there's double that. There's 52 characters. If I have, say, a capital H and maybe a capital K within there, kind of a mixture of those. If you look down at your keyboard, you'll find that actually there's more than just those. I've got numbers and I've got other kind of characters. So the average keyboard is more like kind of 94 kind of characters, in which case, almost 8,000 days. So that's pretty secure. So we should be pretty happy with that. Now the problem occurs, well, how are they going to go and search for things? If I say I could go through my AAAs through to the ZZZs, then I've got 308 million odd different kind of combinations of those different 94 characters. Maybe more, actually. But hacker's actually a word, so well actually I can ignore all the groups of letters that aren't words and just use the recognizable words. If I replace some of the common letters with numbers or symbols, well actually I may have 15,000, but certainly under 100,000, and that's bringing my hacking speed down to less than a minute, even for your average kid in their bedroom. So that's certainly not good enough. So 6 characters, recognised word, not secure enough. Okay, so let's up the number of characters. Let's go up to 15 characters now. So AAAAs through to ZZZZs. So we make sure we don't use any proper words. We just use basically almost a random group of letters and symbols. Not as easy as A, B, C, D, E, F, G, through to O, but it's going to bring the time up, 12 trillion billion kind of years or so. So I think we're pretty secure with that. And we end up with passwords like this. The problem with passwords like that, and I got this one off an online create a strong password website. How would you remember that? How do you remember that? Particularly if you have to change it every month. You can't remember it. The humans are very bad at remembering those kind of things. So we have to find an alternative. One of the alternatives, and there are many different kind of tactics or approaches, but let's look at a phrase that we know. It shouldn't be something as famous as the last 15 words of the Gettysburg Address, but let's just use this as an example. But where it says, of the people, by the people, for the people, shall not perish from the earth. Okay, let's look at those and take the first character of each of those words. So OTP, BTP. And then I can say, well, I can create something which is like a password. And if I then say, well, let's change some of the lowercase to uppercase, and let's change some of the, like the word 4 for a number 4, and an S for a 5, and an E for a 3 in a kind of a dyslexic kind of way, you can say, well, actually, I can create something which is not a recognisable word. So how would that stack up against the rest of it? So 15 characters, it's within the A's through to Z's kind of things, within the 94 character option, and even the fast supercomputer government size kind of computer, we're still looking at 1.2 years. So I think for the time someone to be able to crack that one, I think we're pretty secure. Okay, thank you for listening.